In my opinion, the highlight of Google Colab is the possibility to use hardware accelerator, such as, for example, a GPU, a graphics processing unit. So to configure our runtime to use a GPU, you can go to Runtime, and you go to Change Runtime Type, and here on Hardware Accelerator, you can choose to use none, then you're using just a CPU. You can use a GPU, and you can even use a TPU, which is a tensor processing unit. This is a different story, and we need a completely separate tutorial about TPUs. But this time we are going to use a GPU. So when you save, you can now start using a GPU to run, for example, your deep learning experiments, or to use libraries such as TensorFlow and PyTorch. With the shell command nvidia-smi, we have some information about the GPU that were assigned for this session. So here we can see that we have this Tesla T4. So Tesla T4 is this NVIDIA GPU. You can have more information about this GPU here at NVIDIA website. And we see that it has around 16 gigabytes of RAM. Now, for example, we can write this code here to import TensorFlow and get the GPU. We see that it finds a GPU at GPU 0. What we can do now is, for example, compare the CPU time it takes to processing something using the CPU versus the time that it takes computing the same thing using a GPU. So here we are telling TensorFlow to use the CPU. We are defining here a tensor with random numbers, and then we are defining a convolutional 2D layer. So we will apply this convolutional to this random tensor, and we will see how much it takes using CPU. So it took 224 milliseconds. Now we will copy the same code, but we'll just replace the CPU by the GPU. And when we run this code, it takes 7 milliseconds. So we can see that is way faster using the GPU for this example than using the CPU. We can use this GPUtil that we are installing here with pip install GPUtil, and then we can use a thread, separate thread, for example, to monitor the usage of the GPU. So here I'm importing GPUtil, the threading and the time packages. I'm defining this class to monitor. Class inherits thread. So we have here also the delay, which will be time between the calls to this GPUtil. We set the delay here, for example, every 10 seconds. And then we can, for example, have this loop, and then we have random tensor that will grow every time, every cycle of the loop. So we will use the same example what we use here, but now it's inside a loop, and this tensor is growing. So when we run here, then we can start monitoring. So the GPU using 11% of memory, and it's computing. So every 10 seconds it should display. So now it's already 18% of memory, using 82% of the GPU processing capability. Then it goes to 92%, and it goes to 32% of memory. We can see with this GPUtil, it's basically a wrapper around this NVIDIA-smi, and we can use this way here, for example, in a separate thread to, if we, instead of having this loop, we would have training experiment that's using for example, TensorFlow, Keras, or other things, and this will constantly be monitoring, just if you want to see how the resources are being used. So here you go to this GitHub, YouTube, NDRSKM, you have this documentation how to install and also how to use. For example, here there is this example which I used to monitor the GPU in a separate thread. Here really shows this usage of the GPU capabilities. Have in mind that if you don't pay attention to the limitations of the GPU, especially in terms of memory, and you're running an experiment that demands too much of the GPU. So for example, now we changed here, so this random tensor will grow much faster and it uses a lot of memory. So when we run this, we see that it's already using 97% of the memory the first cycle. This tensor is growing, then we see that we have this problem when allocating the tensor. So we need to always be aware of the limitations of the GPU we are using in order not to have memory problems, especially if we are working with data sets. Sometimes we need to limit our batches or using different strategies not to overload the memory of the GPU.